Dear students, in the last module, we have discussed about software quality assurance as a whole. Today, we will be mainly focusing on the testing, which is one of the branch of software quality assurance. So SQA is now recognized as a subject dealing entire development process, and testing is concerned about the developed software programs. So if we design or build a computer program or software that contains hundreds of thousands of lines, so can we really test each and every line? The answer is probably no. We cannot test each and every line, and we cannot test all of the possible paths from which this program or this software is traversed. So in simple programs, there may be billion of different paths that could potentially be traversed, and testing all paths is in a complex program is nearly impossible. So in such a scenario, what we do? We are doing research in software testing from many years to develop such algorithms, such methods, such techniques that we do not need to test all of the paths being traversed by the software. However, we should be able to identify maximum bugs. So how we do? One of the methodology is inspired from or is known as Pareto principle, that is inspired from economist and sociologist Wilfredo Pareto, and it says it invented that small part of Italy's population controlled most of the Italy's wealth. So when we adopt this Pareto principle in software engineering, we say that small number of modules within a large software system tend to be more problematic than the rest. So that's why we try to identify those modules, those programs which have more bugs and try to correct them. So results can often be increased most rapidly by applying efforts in that particular concentrated area. So another way is basis path testing, that develop a set of test data that ensures that each transaction in the software is executed at least once. Then there is another method known as glass box testing. Software tester is aware of the interior structure of the software and uses this knowledge to test the interiors of the software. Then there is another methodology in software testing known as black box testing. In black box testing, you just consider all of the system as a black box and give the inputs and get the outputs. So you are not concerned in the internal structures which we did in the glass box testing. So we are only concerned that on this input, the required output is achieved, acquired from the software or not. So black box testing is performed from the user's point of view, uses this knowledge. Then there is another approach known as boundary value analysis that identify ranges of data called equivalence classes, and over which the software should perform in a similar manner, and then testing the software on data close to the edges of that range. For example, student marks could be between the range of 0 to 100. So we should test on 0, 1, 99, 100. So these are the boundary values of this particular test. So then there is another beta testing, that is a preliminary version of the product is made available to the clients. And then it is seen that how this system is performing in actual environment. So the segment of the intended audience and the goal of learning how the software performs in real life situations before the final version is released. So based on the comments achieved from the real users, you try to enhance your software. And similar testing can also be done by the developer sides, by the actual developer of the softwares, which is known as alpha testing. So if we summarize today's module, we have learned about what is software testing, what is difference between SQA and testing, Pareto principle, basis path testing, black box, boundary value analysis, beta testing, and alpha testing.